Hey there, everybody. Welcome back. So again, stuff we would normally be doing together. Thought we'd walk through here so we don't lose any time. And we're going to talk about discrimination. A lot of times you always hear a lot of people yelling at you it's discrimination or something else is going wrong. And so here's an example. Engineering firm needs to lay off people. Everybody's equally qualified, etc., so we don't have to worry about any of that. They lay off 10 people, lottery system, 5 men, 5 women. And one of the women claims it's gender discrimination and starts a lawsuit. So the question is there anything there that would make it? So take a second, feel free to hit the pause button. And the manager says, how could there be gender discrimination when half the employees laid off were with female and half are male? What additional information do you need to evaluate this statement? So again, hit pause, take a second, think about what that would be. Alright, so what's the deal? What do you guys come up with? Big thing. We need to know how many men and women work at the company. There's no way we can tell. There's not. If out of the 180 people, 90 were men and 90 were female, then you're like, alright, nothing here to see here, people. So the big question would be, how do you do it? So now, before we can investigate how many men or women, or whether there's discrimination, what we're going to end up doing here is the question, so what would be something that would make sense? What would be a number that would be, yeah, I don't know, maybe it would work, maybe not. So we're going to assume in this section here that there were 60 women and 121 men. There we go. So if there are 60 women and 120 men, what would you do? How do you set up a study or some sort of, not a study, but how do you set up a simulation to make sure that this would work? Now, there's a whole bunch of different ways you could do this. Okay, so we're talking about 1/3 were women, 2/3 were men. So, again, think about random things that we could go through and do that would consistently give us the numbers that we need. So, Comic Sans. So you could use dice. What else? Spinner. You can set that up. Good, you and back. Oops, if I could not accidentally jump my cursor. Random number generator. So the question is, how would you set this up? So on dice, what do you do? You'd say, okay, 1 and 2. That would work. And so men would be 3 through 6 for men. If you had something with a spinner, if you could set up the different things, and if you could set up the different areas in the spinner, kind of like we did yesterday, could say something to the effect of, let's make sure 1/3. Oops. Lost my spot. There we go. You'd say, okay, 1/3 of the area were women, 2/3 are men. Now, for a random number generator, you could do this in a couple of different ways. And again, it all kind of breaks down to how your percentages are. So again, you could say, all right, maybe you do, since we've got 180 people, you could say, okay, 1 through 60 are women. And you would say like 61 through 180 are men. So if you go through, you pull however many we're going to pull, but any number from 1 to 60 are women, 61 through 180 are men, count them off. Now, of course, as we talked about, the difficulty there is that you've got a whole bunch of numbers depending upon how you're doing it and the technology that you potentially are using. If you're using a random number table or something like that, you've got some issues. You could also just simplify it by just simply saying that, if you're going to do integers of 1 through 3, you could say if it's a 1, then that's a woman. And if it's a 2 or 3, is a man. So however you want to do it. Now, the way that I went through and did it was this. I did the dice. And there's a wonderful website called random.org. Where did it go? Apparently I closed it. So then what you just basically do is say, how many dice do you want to roll? And I said, let's roll 10. Because what I ended up doing was, so first things first, I've got this number line set up. So I'm going from, obviously over here, 0 all the way up to 1. I'm counting by tenths because we're going to have a sample size of 10 to make the math easy. And so then what I do is, as I was saying, is I go over to this, there we go, random.org, and there's a whole bunch of different generators here. There happens to be a dice roller, which is nice. So I go to 10 virtual dice, I'm going to hit roll dice, and then I would just go through, and I'm going to simply take what percentage of these are a 1 or a 2. So in this case, 1, 2, 3. So I would say, okay, this is 0.3, is 3 out of 10. So I went through, and I did that 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 times. And that's what I ended up with. So to look at it. So feel free, you can run and do your own, or that's where you get. But when you look at this, what percentage of the dots represent more than half the females being laid off? So in our case, 2 out of 22, which then would be 1 over 11, which is what, 0.0909090909. So So in terms of the context of what's going on, we'd say something like this. assuming the lottery was carried out fairly, because again, you want to make sure that you're not, you're taking everything into consideration. You say, okay, so assuming the lottery is carried out fairly, there is a 9.09%. This is going to do probability to the 0.0909 probability of getting a sample. Proportion of 0.5 or higher. So the question is this really unlikely? And so do we have evidence that there's some sort of gender discrimination? And again, like I alluded to yesterday, there is a threshold of about, I mean, that 95% is really kind of the threshold in terms of saying anything that happens 5% or less, okay, there's some evidence for that. So in this case here, since it happens 9%, which is bigger than 5%, you would say no. Oops. A sample proportion of 0.5 or higher happened fairly often. Now we're going to get more into this as we go, but that's basically what we're going to do. Now, things that we could have done differently. We could have had a larger sample size. 22 is rather small. We could have done 100. Then it would be a little bit more robust. The question is, how big is too big? And that's kind of where we're going to be going for the rest of the chapter. All right. So, 3 big ideas. Ooh, I hate Comic Sans. All right, number 1. First thing that we're going to talk about is this hypotheses. And again, we alluded to these yesterday. Come on, fingers. All right, so a couple things. With a null hypothesis, alternative hypothesis. Null hypothesis is that we're always going to be assuming nothing's going wrong. The alternative hypothesis is the one would be if that's not the case, then what happened? So we've got H, we'll do a little O. Is going to be subscript. We get 2 different options here. Okay, so the null hypothesis we're going to break down into mu or p. So anyway, so you've got the null hypothesis and the alternative hypothesis. So the null hypothesis, you've got what'll end up happening is you basically, and again, depending if you're dealing with mean or proportion, you either say mu or p is equal to the null value. So you would say, all right, in this case, the mean is equal to 5 women are laid off. Now, the alternative hypothesis then is you're going to say, all right, well, if that's the case, then, and this kind of goes back to one of the discussion points we had yesterday, is mu or p greater than or less than or not equal to the null value. And again, that's all going to depend upon context. For important idea number 2, let's remember how p-values work. The way that we're going to use p-values here is the following. The p-value is going to be the probability of getting the results, or more extreme, purely by chance. So again, it's just we're going to play it safe. So if we're saying, if we're looking for, like going back to yesterday, Mr. Hayes makes at least 80%, we're going to look for what's the probability that he's making less than, or like in that case, we were seeing, what, 64%. So what's the probability that we're seeing 64% or less? Because again, we want to cover all the bases. And we would do all of that to see purely by chance if the null is true. So we're always going to assume that the null hypothesis is true, and then we're going to look to see, hey, what's the probability of that happening if that's the case. And then in terms of the conclusions, we are going to simply say we do or do not have convincing evidence against the null hypothesis. So based upon what happens over here with the p-value, we're going to say we do or do not have convincing evidence. The two things that we need in terms of having convincing evidence is this. You need to have alpha is going to be your significance level. So you're going to say 95, so 5% significance, 1% significance. Usually 5% is the threshold that we use. The 1% would be, especially if we're talking like healthcare, that type of thing. As long as p is underneath that threshold, then we're going to say it's significant. If it's significant, then we're going to say, all right, we do have convincing evidence against the null. We'll go from there. All right, so as an example, calcium, vital nutrient for healthy bones and teeth. NIH recommends calcium intake of at least 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers are not getting enough calcium on average. Is this true? So what's the appropriate hypothesis for performing the significance test to find the parameter of interest, etc., etc.? So in terms of what's going on, we'd say, okay, so your hypotheses would be that the null hypothesis is that mu is equal to 1,300. Alternative hypothesis is mu is less than 1,300. The reason why it's not equal to is because the significance up here is that they're getting under the 1,300 milligrams of calcium. So if they're getting more than that, we're fine with it. It goes from there. In the end, just as usual, mu is the true daily mean intake of calcium by teenagers. All right, so we've set everything up. Now let's say researchers perform a test using the hypothesis that we set up above, that the null hypothesis mu is equal to 1,300, and they ask a random sample of 20 teens to record their food and drink consumption for one day. So the researchers go through, figure out the calcium intake for each of the students on average, and they find, or for each of them, and they go through, average it out, and X bar turns out to be 1,198 milligrams. And there's a standard deviation or standard error of 411 milligrams. They go through, perform a significance test, and the p-value turns out to be 0.1404. And again, and we'll go through and talk about how to, I mean, the mean is simple enough, standard error is simple enough, we'll go through and do that. In terms of significance testing, same thing. But we'll talk more about that more specifically as we go. So the question here, number 2, explain what would meaning for the null hypothesis be true to this setting. So in terms of what was going on, this would mean that if the null hypothesis of the mean is 1,300 milligrams is true, the mean daily calcium intake in the population of teens is 1,300 milligrams. So we're going to assume that that's true. In terms of this p-value up here of 0.1404, that would mean this, that assuming that the mean, and again, the wording here is important, so you're going to say, assuming that the mean daily intake is 1,300 milligrams, there is a 0.1404 probability of getting a sample mean of 1198 milligrams or less, purely by chance. So 14%. Now the question is that significant or not? So the conclusion is this, and this is the part where people actually tend to lose 5s on a test. Because the p-value is equal to 0.1404, and that's bigger than, oops, that should be alpha, not a. Change it to symbol. The alpha, so because the p-value is 0.1404, and that's bigger than the alpha value of 0.05, you fail to reject H sub O. And that phrasing right there is huge. For some reason, all my settings are off. So this right here, we fail to reject the null hypothesis. You're not saying that the null hypothesis is true. You're saying that we are failing to reject it. So they're not guilty. I'm not saying they're. So we don't have convincing evidence against the null hypothesis. So all we're doing is saying that we can't say that it's wrong. And that's the full setup. Tomorrow we're going to get a little bit more specific in terms of nuts and bolts of it, but that's the big thing. So, in terms of problems, I'm going to save that for this weekend. I figure you guys are working through Chapter 8 a little bit, and we'll go from there. So I'll give you some problems over this stuff on Friday, and then we can jump into the rest of this. So we will see you then.